Hey guys, so I just wanted to do a quick video of me going through some problems, especially using the flow map that I put on Canvas. I've used this flow map for a couple of years now, and it seems pretty helpful for the kids that are actually face-to-face with me, so I hope that you can get some good use out of it too. But basically, let's kind of start off and let's kind of remind ourselves about the two special types of logarithms that we have. One is a common logarithm, and that's when it's a base of 10. And the base itself is not written, but it's understood that it's there. So when you see a logarithm and you don't actually see a base, you should automatically know it's a common log and that base is 10. Kind of like when we have an exponent, or excuse me, not exponent, when we have a variable x and we don't see a coefficient, we know the coefficient is 1. Also, we have our natural log. That's a base of e, and it's written as the ln or natural log. So you're not going to actually see it written as log base e of x. It's going to be written as ln of x. So just kind of keep those in mind, especially when you're solving equations with exponents and logarithms. When you have e in the problem, you always want to use your natural log so that you can get rid of those pieces. So I'm going to start off with a couple of problems. So basically, I have 40 times 1/2 raised to x over 2 equals 5. So this is an exponential equation. If you start with your flow map, the first question says, does the problem have a log or an ln? Well, of course, we're going to say no. So we're going to go to the right-hand side of the flow map, and it's going to say get b raised to cx by itself. So when it says get b raised to cx by itself, that means that we're going to get the 1/2 raised to x minus 2 by itself. Well, the only way to actually get that by itself is to divide by 40. And once we divide by 40, you're going to get that we have 1/2 and we have 5 over 40. You can simplify that if you want to, or you can leave it as 5 over 40, put it in a decimal. I really don't care as long as you have the exact value and not a rounded value. So I have 1/2 raised to x over 2, and it's going to equal 0.125. So now at this point, the next thing says take the log of both sides. So you can actually take the log of both sides. You can take the natural log of both sides. It doesn't really matter for this problem because we don't have a natural exponent e. So it doesn't matter. But remember, if you're going to put a log on both sides, you got to make sure, 1 to 1. It has to be to both pieces. It can't just be to one or the other. All right, so from here, we take the log of both sides, and then it says, for the next piece, it says use properties of logarithms to expand. So really what that means, when we talk about use properties of logarithms to expand, it means that we're going to take this exponent, and we're going to move it to the front, okay? So once we do that, that leaves me with x over 2 times the log of 1/2 equals the log of 0.125. So really at this point we just need to kind of simplify, and we can plug this information right into our calculator. So I'm going to go ahead and divide by the log of 1/2. And in doing that, so I'm going to kind of bring my information back up here. I have x over 2 equals the log of 0.125 over the log of 1/2. And then, of course, I can go ahead and multiply by 2 on both sides. So if I multiply by 2, so that's going to be 2 times this whole thing. And divided by the log of 1/2. And then you can just basically plug this right into your calculator. I don't know what type of calculators you guys have. However, if you have 84 plus or higher, you can actually use the alpha y equals button, And the first option says numerator divided by denominator, and you should be able to put in a fraction pretty easily. But I'm going to do 2 times, and then alpha y equals, and then I'm going to type the log of 0.125, and in the denominator, the log of 1/2, and I got the x equals 6. And of course, you always want to plug back in and make sure that it works correctly, especially when you start getting negative pieces. Negative pieces can actually come out to be extraneous roots that don't actually work. All right, so now we're going to go to our next problem. So I have 3 plus 2e raised to negative x equals 6. So when I look at this problem, the first thing I think of is that I have a base e, a natural exponent, a natural base, so therefore I know that somehow, some way, I'm going to be using the natural logarithm. So again, if you go through your flow map, it says, do you have a log or an ln? So the answer to that is no. So we're going to basically from there, we want to get e raised to negative x by itself. So the process behind that is we are going to subtract 3. So that leaves me 2e raised to negative x equals 3. I'm going to divide by 2. So I have e raised to negative x is 3 over 2 or 1.5, however you choose to do it. So at this point, we've gotten the b raised to cx by itself. So now I'm going to take the log of both sides, which we've already talked about the fact that instead of taking log, we're going to take the natural log. And in doing that, it then says use the properties of logarithms to expand. So the properties of logarithms means that I'm going to take my negative x, move it to the front. And why do I want to do that? Well, the whole purpose of doing that is because the ln and the e are going to equal 1. So essentially, we're just going to have negative x left. And then I have negative x equals 3 over 2. So we divide by negative 1, and x equals negative 3 over 2. So again, I would still check for my values. So this is going to be checking your calculator, make sure it works, make sure that the answer that you got comes out to be correct. So guys, I actually was plugging this in and I realized that my answer wasn't coming out right. And when I look back at my work, I just realized I made a huge mistake. And right here at this step, I didn't take the log of both sides. So that's definitely something you've got to make sure to do. When you take a log of both sides, you actually have to do it to both sides. And of course, that was a huge mistake on my part. So after getting negative x, I have the ln of 3 over 2. So then I'm going to divide by negative, and then I'm going to take the ln of 3 over 2. And I got x is approximately negative 0.405. So again, what I did over here is not correct. I had to take the ln of both sides. So now if I plug my answer back in, because we had to round, it's not going to come out to be exactly the same answer, but it's going to be close enough that we can understand that that was, I got 5.998, which would round to 6. All right, so then for this one, we have this problem, and we obviously already do have an ln in this problem. So this time we're going to go to the left side of the flow map, and it says use properties to write as a single logarithm. So it is already in a single logarithm. The only issue is that with my logarithm is not by itself. So we need to get just the ln of x minus 3 by itself, so we need to actually move these pieces around. So I need to subtract 4. So this is going to be 3 ln of x minus 3 equals 1. And then I'm going to divide by 3. So that leaves me the ln of x minus 3 equals 1/3. Now at this point, because we only have one logarithm or natural logarithm on one side, we can't just put another natural logarithm on the other side. So in the flow map, it says, is there log on both sides? So the answer is that to no. So in order to solve this, we're going to have to convert this back to exponential form. So just as a reminder that ln is the natural log, so it actually has a base of e. Okay, so when I convert this back to exponential form, my base is still e. I'm going to raise it to 1/3 and set it equal to x minus 3. So again, I have e raised to 1/3 equals x minus 3. And then to solve for x, we're just going to add 3 to both sides. So x equals approximately, and we're just going to go to our calculator, type in e, raise it to 1/3, and then add 3, and I got approximately 4.396. And again, make sure you plug that back in and check your answer. And when I checked that, I got 5.0008, which we know what the actual answer was 5, so that rounds back down to 5 itself. I hope this helps you with just solving logarithms in general, because when you get to your test at the end, you are going to have a calculator inactive piece where I expect you to be able to solve these logarithms. Also, don't forget to check out the video that's probably going to be right after this, where if worse comes to worse, then you do have a calculator, which you have a calculator from the very beginning on your NC Final, how to use your calculator and actually get your answer using the graphing tool. So make sure you check out that video, and then also there will be another video about solving equations with application, like Newton's law of cooling, the Richter scale, and all that kind of good stuff. So make sure you look at all of them.